Alright, these are our notes for section 6.5 on the quadratic formula. Now the quadratic formula is the third method that we're going to learn on how to solve a quadratic equation. So far we've learned how to factor and we've learned completing the square. Factoring only works on trinomials that we can x factor. Has to have three terms and we can x factor it. We also could use greatest common factor in the square root property on those. But in particular, we have to x factor. We're not going to use special cases and stuff. It has to be x factorable to use the factoring method. The completing the square method, that works for any quadratic, but it's kind of messy. It's got several steps, a lot of work involved, sometimes some nasty fractions and square roots, so a lot of people don't like to use it. That's where the quadratic formula comes in. The quadratic formula, like completing the square, will work on any quadratic. And it's just a formula that you have to have memorized. And it's one of those formulas like the Pythagorean theorem that you should know. Okay, so once I give it to you, you need to commit it to memory. Quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac over 2a. Okay, again, it's x equals negative b plus or minus the square root of b squared minus 4ac over 2a. Have that memorized. You're going to need to know it. Now that will give us the roots. That'll give us the answers to our quadratic equation. And all we have to do is plug in the values from the problem for a, b, and c. We get those from the problem, we plug them in, and we simplify it. And it will tell us the answers to our problem. The discriminant is also something you need to know. And the discriminant is part of the quadratic formula. It's the b squared minus 4ac piece of it. Now what the discriminant does is it tells you the type and number of roots you will have, the number of answers you'll get to the problem. So it's nice because you can look at that first, you can figure out the discriminant first, and it will tell you whether you're supposed to have two answers, whether they'll be real, non-real, complex, rational, irrational. It will tell you that beforehand, so you know what types of answers you should have, and then how that applies to your graph. So you do need to know the discriminant also, but it is part of the quadratic formula, so if you have the quadratic formula memorized, you will know what the discriminant is. The next thing we're going to look at is this chart. And in this chart, we're going to talk about how the discriminant tells you the type and number of roots you can get for a problem. There are 4 columns here, so there are 4 different possibilities for the discriminant. And each one of them will tell you a different type and number of roots, and then we'll go through what the graph of that would look like. Our first row here is b squared minus 4az is greater than 0. Okay? If the discriminant is greater than 0, that would mean that it's positive. So when we figure out the discriminant, we get a positive answer. And we're going to add a stipulation to it, and it's a perfect square. Something like 4, 9, 16, 25. Those are all perfect squares. So if you get a discriminant and it's one of those numbers, that's this first row. If you have a perfect square discriminant and it's positive, the type and number of roots you get, you will have 2 real rational roots. Now let's talk about what real and rational mean. Real means it's on a number line. I can look at the x-axis and I'll be able to find where it's at. And rational means that it's whole numbers or fractions. So if we were going to look at our graph, it would cross at 2 distinct points, and those points would be whole numbers or fractions, or some nice decimal, some decimal that cuts itself off. Okay, 1/2 is 0.5, something like that. Whole numbers or fractions. There are distinct places on the number line for those. I don't have to round my decimal. I could actually find it, and that's what rational means, and real means it's on that number line. So for your graph, again, there are 2 distinct points where it crosses, and you could find them on the x-axis. Let's look at the second row. Notice this first part's the same. b squared minus 4ac is greater than 0. So again, it's going to be positive, but we're going to add another stipulation, and it's not a perfect square. Okay, so it won't be 4, 9, 16, 25. It'll be something else. It'll be 15, 14, 13, some other number. If it's positive and not a perfect square, you still get two real roots, but they're not rational this time. They are irrational. Okay, and irrational means they have a square root in them. Okay, some decimal that does not come out nicely. So when we look at our graph, it's a little different. Looks the same. There'll be 2 points where it crosses, but you may have to round to get those points. Something like the square root of 3. Square root of 3 does not come out nicely. That decimal goes on for a while. So you'd have to round it to actually find out and actually put where the 0 would go. And that's what it means by irrational. The graph looks pretty much the same, but you'll have to round your numbers so that you can put them on the x-axis. They're still there. You can find them on the x-axis. You're just going to have to round them to actually put the dot. Next row, b squared minus 4ac equals 0. Now what happens here is if it equals 0, in our quadratic formula, when we actually work it out, it'd be the square root of 0. And the square root of 0 is just 0. So that whole square root part cancels itself out, and the plus or minus. So we would have negative b plus or minus the square root of 0 over 2a. All of this would be gone, and we're just left with negative b over 2a. What happens then is that we only have one real rational root. Okay? You get one answer. There's no more plus minus, so I won't have 2. I'll only have the 1. And when we look at our graph, we've talked about this before, it only hits at 1 point. When it comes down and just touches once, that's called a double root. Okay? It hits it at 1 point and goes back up. That happens if the discriminant is equal to 0. And the last one, and this is the one people don't like, is if b squared minus 4ac, the discriminant is less than 0. If it's less than 0, that means it would be negative. And if it's negative, I will get some negative number underneath my square root in the quadratic formula, which means I'm going to have a complex answer that has an I in it. Okay, and that's why people don't like it, because it's going to have complex numbers. So over here for the type and number of root, we're going to have 2 complex roots. And remember, complex numbers are non-real. Okay, they're imaginary. They don't exist. So when we look at our graph, that parabola doesn't even cross the x-axis. There are no 2 real numbers or 1 real number that actually work for that parabola. They're complex, non-real answers. They don't cross the x-axis at all. Doesn't cross, it doesn't intersect. Okay, and that's important. Complex roots, if a parabola has complex roots, it doesn't intersect the x-axis. Now we've got 3 examples down here, and for these examples, what we're going to do is we're going to find the value of the discriminant. Then using our chart, we're going to go back and give the type and number of roots, and then we're going to use the quadratic formula to calculate the roots. So there are 3 parts to these problems. Let's start with example 1. We've got x squared minus 8x equals 33. Now before we can do anything, we got to get it equal to 0, so we're going to subtract 33 from both sides. And we get x squared minus 8x minus 33 equals 0. And we're going to figure out what the discriminant is. Remember, the discriminant is b squared minus 4ac. So let's plug in our values. b is negative 8 minus 4 times a, which is 1. And then c in this problem is negative 33. Negative 8 squared, and this is important that you realize this, negative 8 squared is 64, positive 64. Minus 4 times 1 times negative 33, well, minus 4 times negative 33, that's going to be a big number. 132, so we get 64 plus 132, and when we add those together, we get 196. Now it's positive, which narrows it down to the first 2 rows up here. Our discriminant's positive, and we need to figure out if it's a perfect square or not. 196 is a perfect square. It's 14 squared. So when we look to figure out the type and number, we will look at the first row. It's going to have 2 real rational roots. And that's because it's a perfect square. The last thing we're going to do is we're going to use the quadratic formula to actually find the roots. And what's nice about doing the discriminant first is we've really done half of the work. We've done half of the quadratic formula already. We figured out what b squared minus 4ac is. So when we plug it in, we'll have x equals negative b, and in this case b is negative 8, plus or minus the square root of, I already figured that out, 196 over 2 times a, which is 1. So we get 8 plus or minus square root of 196 is 14 over 2. Now we need to figure out what those are. That's really two answers. That's 8 plus 14 over 2, 8 minus 14 over 2. Well, 8 plus 14 is going to be 22, and then we cut that in half and we get 11. So this answer is 11. And 8 minus 14 is negative 6 divided by 2. That gives us negative 3. So the answers to our problem are negative 3 and 11. And notice we did get two rational answers. We got two whole numbers. Two things that we could actually find on the number line, which means they're real, and they're whole numbers. They're not nasty decimals, and they don't have a square root in them. So that's good. We did that one correct. Let's look at the next one. X squared minus 6x plus 2 equals 0. Well, that's already equal to 0, so we're good there. We don't have to move anything. We can go ahead and figure out the discriminant, which is b squared minus 4ac. b in this problem is negative 6 minus 4 times a, which is 1, times c, which is 2. Negative 6 squared is going to be 36. And then negative 4 times 1 times 2 is negative 8. So we get 36 minus 8, which is 28. There's our discriminant, 28. It's positive again, so that narrows it down to the top two rows. It is not a perfect square. So it's going to have two real irrational roots. Since it's not a perfect square, they won't be rational. Now we're going to use the quadratic formula to find those roots. So x equals negative b, which is negative 6 for b this time, plus or minus the square root of 28, because we already found that, over 2 times a, which is 1. So we have 6 plus or minus the square root of 28. Well, that's going to break down. 7 and 4. So it's really 2 square roots of 7 over 2. That will simplify, because we check and see if there's any common number that will go into all of those numbers out in front. Well, 6, 2, and 2. 2 goes into all of them. 2 goes into 6 3 times, plus or minus. 2 goes into 2 once, so it's square root of 7. And then 2 goes into the other 2 once, so it's over 1. And those are our two answers. Those are the last part of the problem. 3 plus the square root of 7, and 3 minus the square root of 7. And if we put it in brackets, it would be 3 plus minus the square root of 7. You could split it up if you want. You don't have to, but there's really two answers there. You need to remember that. Last thing here, example 3. We need to figure out what the b is, and b is not on the side with everything else, so we're going to subtract 6x from both sides. So we get x squared minus 6x plus 13 equals 0. Let's plug in what we know. B squared minus 4ac. B squared is going to be negative 6 squared minus 4 times 1 times 13 is c in this problem. Negative 6 squared is going to be 36, positive 36. And negative 4 times 13 is going to be negative 52. When we have 36 minus 52, we get negative 16. All right, we have a negative value for our discriminant. That tells us we're going to have two complex roots, right? Which means they'll have I in them. Two complex roots. Let's figure out what they are real quick. Let's plug it into the quadratic formula. Negative b. b is negative 6, so I forgot my x equals. Plus or minus the square root of negative 16 over 2 times a is 1. So 6 again. That's two problems that I've had 6 in them, which is nice. Plus or minus square root of negative 16. Well, 16 is a perfect square, and it's got a negative under there, which means we're going to make it I square root 16. Square root of 16 is 4, so it's plus or minus 4i over 2. Again, there is a common number that goes into all of those, 6, 4, and 2, and it's 2. 2 goes into 6 3 times, plus or minus. 2 goes into 4 twice with an I, and then 2 goes into 2 once, so there is no more fraction. And those are the two answers to the problem, 3 plus 2i and 3 minus 2i. Now I realize that's all pretty cramped there at the bottom, and I apologize. But if you have any questions on this, you should bring them to class next time. You do need to know the quadratic formula, so make sure you have it committed to memory. And the discriminant, which is part of the quadratic formula. If you have any questions, again, bring them to class next time. Otherwise, those are your notes on section 6.5 on the quadratic formula.